I've recently received a ton of questions regarding this specific passage on the sample AAMC exam. So if you haven't taken that exam, this is a spoiler alert right here. I'm going to cover this passage as briefly as possible, just to explain a couple things about it. The passage starts by stating that terpenes constitute a class of non-saponifiable lipids whose carbon skeletons are composed of isoprene units. Notice this says 2-methyl-1,3-butadiene, so none of these structures down here as shown are actually that molecule as shown. The 2-methyl, if we number this molecule, when it says 1,3-butadiene, it tells us that we have double bonds right here and right here. All right, anyway, moving on. In human metabolism, a squalene C30 terpene compound 1 is utilized as a precursor for synthesis of many lipids. All right, so here is compound 1, and this is going to be a precursor for cholesterol as well as everything that is then derived from cholesterol, such as all of your steroid hormones, estrogen, testosterone, as well as your bile acids. Moving on further, this is where the vast majority of our discussion here is going to focus because this reaction is what seems to be tripping people up the most. All right, so this goes on to say that mevalonate, compound 2, is a key intermediate in squalene biosynthesis, the biosynthetic pathway by which optically active mevalonate, so notice it says optically active, that tells us that what? That tells us that it's chiral, right? Because meaning that it rotates plane polarized light either clockwise or counterclockwise depending on which way it's synthesized. The biosynthetic pathway by which optically active mevalonate is synthesized in vivo from acetate has been elucidated using specifically C14 labeled acetyl-CoA reactions 1 through 3. So this shows us that we're going to be radioactively labeling some of our carbons in the acetyl-CoA molecules that we're starting out with. So here we're just going to go ahead and highlight the carbons that are radio labeled here. Okay, so see we highlight these two and those go on to form acetyl-CoA via thiolase as the enzyme. All right, so that's fine. And that's not where people have been struggling because you can see how this plays out because it shows the labeled carbons in the product as well. So where people have really been struggling here, it seems, is in this next reaction where it shows the second subunit of acetyl-CoA reacting with that acetyl-acetyl-CoA that we just synthesized. So again, here are our two carbons in the acetyl-acetyl-CoA that we just synthesized. And I'm going to go ahead and label with a different color the carbon that's radio labeled in acetyl-CoA. So just note that whether it's green or yellow, that means that it's C14 labeled. I just want to be able to keep track of which carbons come from acetyl-CoA and which ones come from acetyl-acetyl-CoA. I'm going to go ahead and draw these molecules out over here to the side so we can do some electron pushing and look at what's actually going on in these reactions. Due to video length limitations on some of the social media platforms, we're going to make this a 3-part series, so go ahead and check out our next video for the complete synthesis of this reaction, and then part 3, we will actually answer all the questions associated with this passage. Thanks so much.